Hello, welcome to the podcast that explains this GeoGebra app that I have made called Linear Pattern Generator with input evaluation. So what this is it allows us to create any linear pattern we want, where we can specify the number of input-output pairs that we want to look at. So whether we want to look at 1 or 4 or 28, for instance, which we can just change our scale and we can see the nice linear pattern here. Um, One thing about GeoGebra that I really do like is changing the scale, because it really helps, especially when kids, if our students use these apps, then they can understand how to start counting scale differently instead of just giving them standard graph windows all the time. But this app allows us to, again, change the number of terms that we want to see in our pattern. Okay, we could also change our first term in the linear pattern. I got it set to 4 right now, but notice as we change our first term, it's a nice translation, right? Even if we show more points. It's a nice translation of our points here. And then the difference, which is our slope changer, as we change the difference around, we can see our slope change. The cool thing too that I like about the lines is that I did this in hopes that our students would understand input and output, when we talk about ordered pairs. So when they see an ordered pair, they need to think about the x equals line, the y equals line. When I put all these in, it was kind of neat for me to see the GeoGebra happening, or not GeoGebra, the geometry happening here of our slope, basically. As we think about our rise and our run, it creates these nice rectangular shapes here. So we could change, right? There's some similarity talk we could do, but depending on our slope, it changes our rectangle, so it's kind of neat. Yeah, we change the first term, change our difference, make any sequence that we want. Okay, change the number of terms here. Now, what I thought was kind of neat too is I added the evaluate for input value. Now, if we click on that, what pops up is we can change our input either by the box that we want to solve for, like the first term, second term, third term, whatever term. And I also put in some negative terms here because in my class, I'm extending sequence thought past the domain of our counting numbers, thinking about the 0th term, because when we do the 0th term, that's where we can get to the slope or the y-intercept. So as we change the input value to 0, notice it goes to the y-axis here, which fits our nice linear pattern. So we can have students go from the first term to the 0th term, which will lead into the y-intercept. Also, I put this nice little dynamic sentence in here saying that if you're inputting a 0, the output tells us what our output's going to be. Okay, so the nice thing too is as we change, and this is only set up for the positive inputs into a sequence, but what I like about it too is it shows from the first term, which in this case is set to -7, and it has a difference of, let's make it a different, well, it's 3.5. As we evaluate, like we're evaluating the third term and we get out of 0, you can see how our terms are increasing by 1 and our output is increasing by our difference. So you can see our nice arrows here that are showing the evaluation, which in my class, again, it's just making concrete our formula rule for finding terms, which we say, start at your first term, and we're adding our difference applied 1 less than the term number. So the third term, you can see by the red arrow that our difference is getting applied twice to our first term output here. So we can change the input value, which is really nice, showing us really what's happening here. And again, it's just making in concrete here our slope concepts. As x increases by 1, our outputs, or term values, are going to increase by, in this case, 3.5. Okay, change the first term maybe to a positive. So maybe a +4, but a difference of -3. But still, as we evaluate, we can see this rise and run concept. I didn't make the arrows go for the negative, but still, it's a good extension to think about. The pattern still happens, but now with this one, we can evaluate points, and we can change and make any arithmetic sequence or linear sequence that we want to.